So we're going to talk about solving two-step equations, and we're going to do a quick review of one-step equations. The key to solving equations is always inverse operations. And these are two operations that undo each other. So if our operation is addition, the inverse is subtraction. If our operation is subtraction, the inverse is addition. If our operation is multiplication, the inverse is division. For division, the inverse is multiplication. If something is squared, the inverse is the square root of that thing. These operations undo each other, so the square root of x squared is just x. And if something is square rooted, the inverse operation is squaring it. So if I have the square root of x and I square it, that's equal to x. They undo each other. So for quick review, if I see addition, I do subtraction. What I do on the left, I do on the right. X is equal to 0. 5 minus 5 is 0. Maybe I should have done one that doesn't equal 0. If I see subtraction, I do addition. What I do on the left, I do on the right. X is equal to 15. If I see multiplication, and this is what multiplication looks like in algebra, we're not going to have a multiplication sign, right? We're just going to have a variable and with a coefficient. I do division. What do I do on the left? I do on the right. X is equal to 3. And if I see division, which will always look like a fraction in algebra, I will multiply. And what I do on the left, I do on the right. So two-step equations are just like unwrapping a present. You have to think what is closest to the present is going to come off last. And so when we wrap a present, when we do wrap a present, first we put the present in a box, and then we put the box in paper. But when we are undoing that, right, we have to take the paper off first. So first the paper, then the box. And so we're going to talk about things in terms of which one is more like the box when we're looking at two-step equations, and we'll see some examples of that below. So we do evaluate expressions using GEMDAS. The way we undo it, solving equations, is by using SADMEG, which is GEMDAS backwards. And you're still evaluating subtraction and addition together, division and multiplication together, followed by exponents and grouping. So undo your addition and subtraction first, undo your multiplication and division, then exponents, then grouping. And I'm going to show you some examples of what I mean by SADMEG. So the first thing that we're looking at is getting rid of the addition and subtraction. I see this addition, I do subtraction. It's the opposite. I'm left with 10p equals 80. And we're looking for 0 pairs. Those add up to 0, and so it's quote unquote gone on the left hand side. It's not really, but it's a 0. I see multiplication, so now we're here. We evaluated for, we undid the subtraction and addition. Now we're going to undo the division and multiplication. I see multiplication, I do division. What I do on the left, I do on the right. P is equal to 8. Let's try a couple more. Oh, nope. First, the things we're going to try is that we know it's correct if we can substitute it back into the original equation and it evaluates to be a true statement. We have 80 plus 9 is equal to 89, and finally 89 is equal to 89. So we've done this one correctly. All right, let's try another one. So again, SADMEG, look for addition and subtraction first, and this is the one that is, this is the paper in this situation. So this is closer to the variable. That means that this is our, if we're using our present analogy, this is our box, okay? This multiplication is the box. Stopped recording. I don't know what I did. All right, sorry. All right, so let's try another one. Using SADMAG, this multiplication is closer to, this is the box in our present analogy. So we're going to undo the addition and subtraction first. What I do on the left, I do on the right. This makes a zero pair, so I'm left with negative 2b is equal to 20. Now we look to undo the division and multiplication. Divide both sides by negative 2, and we're left with negative 10. Let's put negative 10 back into the original equation and see if it works. Negative 3, negative 2 times negative 10 is equal to 17. Yes. Let's do a couple more. So again, using SADMAG, we're going to do the equivalent of taking the paper off first. I see subtraction, I do addition. What I do on the left, I do on the right. I'm left with x over 15 is equal to 1. I see multiplication, I see division, I do multiplication. What I do on the left, I do on the right. These make a 1 pair, and I'm left with 15. I can substitute that back into the original equation and see if I have solved correctly. Oopsie. And I did. So last one for today, using SADMAG. I see addition, I do subtraction. What I do on the left, I do on the right. And this is a case of where we have an invisible operator before this 8. Since we don't see anything out in front of there, we have to assume it's a plus sign. N is equal to 8. Substitute it back into the original equation. 8 plus 4 equals 12. 12 equals 12. Thanks for watching, and I hope this was helpful.